So quiz 2 key. Again, always for these nomenclature naming ones, find the parent name. The parent name here is hexanol, 1-ol. So 1, 2, 3, 4, 5, 6. 6 for hexane. The alcohol is not part of the carbon chain. A lot of folks wanted to make the oxygen part of the carbon chain. There's 6. Hex means 6 carbons. Diethyl, so oxygen has 1, 2, 4, the 2 ethyls, and then 3 for the bromo. Butane propanamine, again, the parent name is butanamine. So but is 4 carbons, 1, 2, 3, 4, and then a nitrogen on the end. So this would be considered the parent chain, right? And if we only have one thing off the nitrogen, N-propyl, right? We don't use numbers for amines. We use N to indicate things are off the nitrogen. Propyl means 3 carbons, 1, 2, 3. And if there's nothing else, we need to draw in the H because we know that there should be an H there because nitrogen wants 3 bonds. This one, parent chain again is always the ring, no matter how small it is. It's the ring, so it's cyclopropane, and it's 1, 2, 3, 4, 5 pentyl, 1 pentyl cyclopropane. Parent chain always goes at the end. Some folks had this at the beginning, this at the end. Some people try to add in that carbon, right? Circle the parent chain. Make sure that parent chain is at the end. That's kind of your guiding principle. Correct arrows with resonance structures. So this one, you were given the structures, so you got to kind of get a feel for where the electrons are moving, right? So here, these electrons are going to the nitrogen. Notice it has the lone pairs weren't drawn in, but if you see a nitrogen with 3 bonds, you assume it has a lone pair. So, right, draw in lone pairs always. Biggest thing I saw from folks, people try to move the plus charge with the arrows. The arrows move electrons, right? So you have to move a pi bond or a lone pair. Never move a plus charge. Pi bond moves here, makes a new pi bond, plus charge there. And then which would be the lowest likely structure. Octet rule is the first thing you ask versus worrying about which atom is more electronegative. So the answer is A, because everything has a full octet. So this one, label the hybridization state for all the atoms, right? So some folks forgot to do all the atoms. So all the atoms, so no pi bonds, sp3, sp2, sp2, sp3, sp3, because this oxygen doesn't have any pi bonds. It has lone pairs, but it's not 1 bond away from an atom with p orbitals, right? It's too far away from this atom. So sp3, sp3. What hybrid orbitals are the lone pairs in the box oxygen located? Because it's sp3 hybridized, it only has sp3 hybrid orbitals, so it's sp3. And what are making the sigma bond between the box oxygen and carbon atoms? That's because this is sp3, that's sp3, it has to just be an sp3 orbital, sp3 making that sigma bond. For this one, boiling point has a lower boiling point, make sure it has lower. These things have more London forces. This has more London forces. This has less. Less forces means less intermolecular interactions, intermolecular interactions. So this would have the the lower boiling point. So it'd be easier to boil. But again, a lot of people said something about bonds breaking. There's no bonds breaking in boiling.
I thought it had to be